Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. So here we're finding the limit as x approaches 0 of e to the x minus 1 over 3x squared plus x. If you try to plug in 0, you're going to get 1 minus 1 here. So that goes to 0. And if you try to plug in 0 down here, you're going to just get 0 plus 0, which is 0. So we have a 0 over 0 indeterminate form, which tells us we can try L'Hopital's rule. I've written down here L, the equals, and now we're going to take the derivative of the top, which is going to be e to the x, and the derivative of the bottom, which is going to be 6x plus 1. But now if we try to plug in again, we're going to get something that's not an indeterminate form. So that's going to be 1 over 0 plus 1, which is just 1. Okay, so for this one, we could not have used factoring. All right, so for this one, we have the limit as x approaches infinity of 4x cubed minus 3 over natural log of x plus 5. Think of just taking the limit of the top and the limit of the bottom. So as x goes to infinity, what's happening to 4x cubed minus 3? It also goes to infinity, that's right. Okay, as x goes to infinity, what's happening to natural log of x plus 5? You might want to think about the graph of the natural log of x. And it looks like a reflection of e to the x across the line y equals x. Goes through the point 1, 0, goes through the point e1, looks like this. What's happening to the natural log function, the y values of the natural log function, as x goes to infinity? We're talking about the right-end behavior of the graph, right? Yes, it's going to go to infinity as well. It goes kind of slowly, but it does just keep increasing forever. Even though it's not very steep, it is increasing. Infinity plus 5, that's also going to go to positive infinity. We have an infinity over infinity indeterminate form. I remember L'Hopital's rule applies whether you have 0 over 0 or infinity over infinity, either way. So we can use L'Hopital's rule, which I abbreviate L'H. Okay, so we have the limit as x goes to infinity of 4x cubed minus 3 over natural log of x plus 5 equals, with a little L over the top. And then we're going to have the limit. Make sure to write your limit each step needed until you've used it up. So we're going to have limit as x goes to infinity of 12x squared over 1 over x. All right, so at this point, let's think about the limit of the top and the limit of the bottom. So this guy is going to go to infinity. This guy is going to go to 0. So that's not very helpful. What can we do to rearrange that? It's not a L'Hopital's rule form. So let's use some algebra. So this is the limit as x approaches infinity. Notice I'm not writing an L because I'm not using L'Hopital's rule. I'm just using algebra of 12x cubed. Then what happens to 12x cubed as x approaches infinity? It goes to infinity. That's right. So this limit is positive infinity. You could also say it doesn't exist. Remember, a limit that is infinity means that the limit doesn't exist. But when you say infinity, it gives more information. It explains in what way it doesn't exist. So it's more specific. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.